So given two sinusoidal quantities of the same frequency, how do we determine which of them is leading and which of them is lagging? Now that is exactly what we are going to do in today's video. So if you are new here, make sure you subscribe to this channel, like this video and share this video to all your friends. Now before we start solving more complex examples, let's try this simple example. Given that we have V1 to be a sine omega t plus 50 degrees, and then we have V2 also to be a sine omega t minus 30 degrees. Now we have A to be the amplitude of the signal, we have omega to be the angular frequency, omega t to be the argument, and then we have 50 and then negative 30 to be the phase angles of the two signals V1 and V2 respectively. Now to identify which of them is leading and which of them is lagging, there are basically three things that we need to do. First of all, we need to make sure that the two signals are of the same form. So the two signals, that is V1 and V2, need to be of the same form. So if V1 is a sine wave, then V2 must also be a sine wave. Now if V1 is a cosine wave, then V2 must also be a cosine wave. If V1 is a sine wave and then V2 is a cosine wave, then we need to convert V2 from its cosine form to the sine form. So always we need to make sure that the two signals are of the same form. Secondly, we need to make sure that the amplitudes of the two signals are always positive. So the two signals must have positive amplitudes. So we need to make sure that V1 and V2 have positive amplitudes. And then thirdly, we can compare their phase angles and then we can determine which of them is leading and which of them is lagging. So we compare their phase angles. So first of all, you make sure that the two signals are of the same form. Secondly, you make sure that the two signals have positive amplitudes. And then lastly, you can compare their phase angles to determine or to identify which of them is leading and which of them is lagging. So having this in mind, let's try to solve this example. So we are given V1 to be a sine omega t plus 50 degrees, and then we have V2 to be a sine omega t minus 30 degrees. Now when you compare the two signals, you realize that they have the same form. That is, the two signals are all sine waves. And then secondly, they have positive amplitudes. So we are good to go. And then thirdly, we can compare their phase angles to find which of them is leading and which of them is lagging. Now to do so, you realize that the phase angle of V1 is 50 degrees and the phase angle of V2 is negative 30 degrees. Now we can express V2 to look like V1 so that it becomes very easier for us to compare the two signals and then find the phase difference and hence which of them is leading and which of them is lagging. So this is what I mean. We have V1 to be a sine omega t plus 50 degrees, and then we have V2 also to be a sine omega t minus 30 degrees. Now we can express negative 30 degrees as 50 plus a certain value, which will also be equal to negative 30 degrees. Now you realize that 50 plus negative 80 is equal to negative 30 degrees. So instead of writing negative 30 degrees, we can express that as 50 plus negative 80. And 50 plus negative 80 is the same as 50 minus 80. So we are going to write plus 50 minus 80. Now if you should express V2 this way, then it becomes very easier for you to compare the two signals. So comparing the two signals, you realize that we have the phase angle of V1 to be 50 degrees, and we have the phase angle of V2 to be 50 minus 80 degrees. Now you realize that we have 50 here, therefore the difference is negative 80 degrees. So basically 80 degrees is the phase angle between the two signals. Now since V2 has negative 80 degrees, then it means that V2 lags V1 by 80 degrees. So first of all, we have the phase angle between the two signals to be 80 degrees. So we can say that V2 lags V1 by 80 degrees, or better still, V1 leads V2 by 80 degrees. So basically that is how to determine the phase angle and which sinusoidal quantity is leading or lagging. Now let's try more complex examples. So for example 1, we are going to calculate the phase angles between I and V, and also we are going to state which one is leading. Now we have A. We have I to be 10 sine omega t minus 20 degrees and V to be 20 sine omega t plus 80 degrees. For B, we have I to be 50 sine omega t plus 90 degrees and V equals negative 20 sine omega t plus 90 degrees. So let's solve these examples together. So for A, we have I to be 10 sine omega t minus 20 degrees, and then we have V to be 20 sine omega t plus 80 degrees. Now when you compare the two signals, you realize that the two signals have the same form. That is, they are both sine waves. They have positive amplitudes. So for that matter, we can compare their phase angles. Now we have I to be 10 sine omega t minus 20 degrees. Therefore, the phase angle of I is negative 20 degrees. And also for V, we have 20 sine omega t plus 80 degrees, which means that the phase angle of V is also 80 degrees. Now to compare the two signals, we are going to express V such that it's going to look like I. So instead of writing 80 degrees as the phase angle for V, we are going to express that as negative 20 plus a certain value, which should be equal to 80 degrees. Now negative 20 plus what value do you think will be equal to 80? Negative 20 plus 100 is equal to 80 degrees. So we are going to replace 80 by negative 20 plus 100. So we have negative 20 degrees plus 100 degrees. Now comparing the two signals, you realize that we have negative 20, we have negative 20. Therefore, the difference is 100 degrees. Therefore, we say that the phase angle between the two signals is 100 degrees. So phase angle is 100 degrees. And since the phase angle for V is plus 100 degrees, it means that V leads I by 100 degrees. So V leads I by 100 degrees. Now let's move on to B. So also for B, we have I to be 50 sine omega t plus 90, and then we have V to be negative 20 sine omega t plus 90 degrees. Now you realize that even though the two signals are of the same form, the amplitude of V has a negative value. Therefore, we need to make sure that we have a positive value. Now to do so, we are going to remove the negative attached to the 20, and that results to reversing the signal. That is, we are going to add 180 degrees to this phase angle. So if we have I to be 50 sine omega t plus 90 degrees, then reversing this signal, we are going to have V equals, this time we have a positive amplitude, then sine omega t plus 90, and then we are going to add 180 to it. So that becomes omega t plus 90 degrees plus 180 degrees. Now when you compare the two signals, you realize that we have 90 here. Now the difference between the two signals is 180 degrees. Therefore, we say that the phase angle between the two signals is 180 degrees. So the phase angle is 180 degrees. And since the value is positive, then it means that V leads I by 180 degrees. Now let's move on as we solve more examples. So for example 2, we are going to calculate the phase angles between I and V like we did in the previous example, as well as stating the one which is leading. So for A, we have I equals negative 10 cos omega t plus 50, and then we have V to be 12 sine omega t minus 10 degrees. Also for B, we have I equals negative 4 sine 377t plus 25 degrees, and V equals 5 cos 377t minus 40 degrees. Now let's solve these examples together. Now for A, you realize that the two signals are of different forms. We have I to be a cosine signal, and then we have V to be a sine signal. Now because the two signals are not the same or are not of the same form, then it is very important that we convert one to the other. Now since we have a negative amplitude for I, then it is better we convert I from its cosine form to the sine form. Now to do so, there are some basic trig identities that we should be familiar with. Now the first one is cos omega t is equal to sine omega t plus 90 degrees. Now if you have a positive amplitude for a cosine waveform, then that should be equal to sine of omega t plus 90 degrees. That is, you are going to add 90 degrees to the phase angle. Now if you have negative cos omega t, then basically that is equal to sine omega t. This time we are going to subtract 90 from the phase angle. Sine omega t is equal to cos omega t, this time minus 90 degrees, and then negative sine omega t is equal to cos omega t plus 90 degrees. So take notice of these four trig identities. If you have cos omega t, then because we have this to be a positive amplitude, then you have plus 90. Negative, you have negative 90. Now for sine, if you have a positive amplitude, then that is negative 90 degrees. You are going to subtract 90 from the phase angle, and then if you have negative amplitude for a sine waveform, then that is equal to cos omega t plus 90 degrees. So basically, if you are going to convert one signal from one form to the other, then you may use one of these four trig identities. Now, since we have I to be a cosine waveform and having a negative amplitude, then that corresponds to the second one. So basically, we are going to use negative cos omega t equals sine omega t minus 90 degrees. Therefore, I, which is equal to negative 10 cos omega t plus 50 degrees becomes, so we are going to have a positive amplitude, so that changes to 10. The form of the signal changes. We have sine and then omega t plus 50, this 50. Now we are going to subtract 90 from the phase angle, so minus 90 degrees. So finally we have I to be 10 sine omega t plus, or better still, minus 40 degrees. So this is I. Now for V, we have V to be 12 sine omega t minus 10 degrees. Now we can represent negative 10 degrees as negative 40 plus a certain value that will be equal to negative 10 degrees. Now negative 40 plus 30 will be equal to negative 10. So instead of writing negative 10 degrees for the phase angle of V, we are going to represent that as negative 40 plus 30 degrees. So we have V equals 12 sine omega t minus 40 degrees plus 30 degrees. Now we have negative 40 here. We also have negative 40. The phase angle between the two signals is 30 degrees. So we have phase angle between the two signals to be 30 degrees. And because this phase angle is positive for V, then we say that V leads I by 30 degrees. So V leads I by 30 degrees. Now let's move on to B. So for B, we have I equals negative 4 sine 377t plus 25 degrees. We also have V to be 5 cos 377t minus 40 degrees. Now we have I to be a sine wave, we have V to be a cosine wave. Now since the amplitude of I is a negative value, then it is more appropriate to convert I from the sine form to the cosine form. Now negative amplitude for a sine wave corresponds to the fourth one. So we have I, which is equal to negative 4 sine 377t plus 25 degrees to be, so the negative amplitude changes to positive. So we have 4. The form changes. We have cos omega t. We have 377t. So 377t plus 25. And then we are going to add 90 to it, so plus 90 degrees. That is 25 degrees plus 90 degrees is 115 degrees. So we have I to be, we have 4 cos 377t plus 115 degrees. And then we have V to be 5 cos 377t minus 40 degrees. Now we can express negative 40 as 115 plus a certain value that is equal to negative 40. Now 115 plus negative 155 is equal to negative 40. Therefore, we can express negative 40 as 115 minus 155 degrees, and then 115 minus 155 is negative 40. Therefore, we have 115 here. We also have 115 here. The phase angle between the two signals is 155 degrees. Therefore, we have the phase angle to be 155 degrees. And since the value is negative, it basically means that V lags I by 155 degrees. Therefore, I leads V by 155 degrees. So that's it for today's video. Thanks for watching and see you in my next video. Bye bye.